Greetings. Today's connectivity training, we're going to be looking at numbering systems, counting, and having a bit of fun with maths. So we look on the screen here, we can see there are some writing that we might say is Arabic. There's some writing here we might say perhaps is Mandarin. How did we recognize them? How do we know that's what they are? This comes through us recognizing them by sight, but understanding what they look like. In communications, we are going to be using different numbering systems. Just as we have different alphabets here, we'll use different numbering systems. And to become an expert at comms, being fluent in 3 of these numbering systems will help immensely. What are the 3 numbering systems that we're going to use? It's decimal, hexadecimal, and binary. Luckily, all of us are already fluent in one of those, at least in the decimal system. It's the numbering we use every day. But before we start to look at them, a little bit of history about where they came from might help us understand a few things. So the earliest records we have, about 3000 BC, the Egyptians were representing things in their own numbering system. If we look at it today, a bit cumbersome, it went from right to left. So 23 was written as 2 on the right-hand side and 3 on the left-hand side. In the day, it probably worked extremely well for them. But they had no 0, and the first time that we see a 0 mentioned is about 300 BC in India. Now, with the trade going on the Silk Road between the East and the West, and also from north to south, having the Arab world as its center of the crossroads, they all wanted to use a very similar numbering system. So everyone had a look around. In Europe, we were using the Roman system, which was V11 for some numbers, X1, V, very quite cumbersome. And especially if you weren't used to it, as the people in the Far East weren't. So the numbering system that was chosen was the one from India, and it probably just evolved. And because the Arabs in the center part of the trade route were using it, and so everyone else followed suit, this meant that people knew exactly how much they were paying for things, and no one was undercharged or overcharged, and everyone was happy. This got to be called the Arabic numbering system. And today we still call the numbers that we use the Arabic numbering system. And there's a little story I've got there of how we probably came to call it the decimal system as well. Decimal meaning we count in tens. So recap the Roman numbering system, bit cumbersome if we look at it today. If you were fluent with it in the day, it was probably very useful. But the Arabic numbering system, the one we're all fluent with, the decimal Arabic numbering system, we're quite familiar with how that works. Now, we use the word Arabic, and what we need to know is an interesting fact is that we write our numbers from right to left. We write our words in English using the Latin alphabet. We write from left to right. Arabics write their letters, their words from right to left, and so do other countries who might use Hebrew. They write from right to left. So the interesting fact here is the Arabic numbering system is from right to left. Now, You say, well, I put my numbers down 1,234 and I went from the left to the right. I agree with you. Have you ever tried to count up a series of numbers that are justified to the left-hand margin and start counting from the highest down to the lowest? It doesn't work that way. We start from the lowest to the highest, and we also need to have it against the right-hand margin so that all the numbers are underneath each other, then we can count them. So we count from the right-hand side to the left-hand side. So if you're ever going to write software, remember that you need to justify it to the right-hand side and grow it to the left-hand side. So let's have a look at this decimal Arabic numbering system. Decimal system, we know, counts in tens, base 10 counting systems. Numbers are displayed. As we could see here, we have the number 23, and it's base 10, 10 below the line, base 10. The decimal system starts counting at 0. Very important point, we start counting at 0. We go from 0 and we count to 9. When we reach 9, that column becomes a 0, and we carry one over to the left-hand side. As we grow the number to the left-hand side, remember that we write our numbers right to left. So as an example, we start off here 3 columns of numbers, everyone's 0, and we start counting 1, and we count all the way up to 9. When we carry 1 to the left-hand column and the right-hand column becomes a 0, and we count up both columns until we get to 99, where we carry 1 over to the left-hand side, the others become 0, and we have 100. So the decimal system, we count in tens, starting from 0. Please remember we start from 0. It will catch you out later on. Hexadecimal system. Hexadecimal system, we count in 16s. How on earth can that be possible? We only have 9 numbers. Well, after 9, they start using characters from the Latin alphabet, A through to F. So we would have a number, as we can see here, to E base 16. It means this is a hexadecimal number. There are other ways of displaying these. We can go 0x2e, 2e with a small h, 2e base 16. With practice, you will become fluent in hex, and to be an expert in communications, you need to be fluent in hex. Once you're fluent, you can usually pick out whether a number is a hexadecimal number or a decimal number or a binary number. Another interesting fact is that in the hexadecimal system, 10 is equal to 16 in the decimal system. So let's look at how we count up in the hexadecimal system. We start at 0. As we know, counting starts at 0. We count 1 to 9. Then we start using characters from the Latin alphabet, A through to F. And then we carry 1 and the right-hand column becomes a 0 again. And so we do this until both columns are F, F, where we carry 1 to the left-hand side and all the columns on the right-hand side become zeros. The third system we use is the binary numbering system. The binary numbering system, we count in 2s, therefore it's base 2. A digit can either be a 1 or a 0. So we start at 0, we count to 1, and then we carry 1 and that column goes to 0. So we have a whole set of zeros. We count to 1. We move the 1, carry 1 over, and the right-hand side becomes 0, and we carry on like that all the way up. So that is the binary numbering system. Again, it starts at 0, and there are 2 items, so it's a base 2 numbering system. So we put it all together. We have 3 numbering systems we need to be fluent in: the decimal, the hexadecimal, and the binary. Now remember, wherever you are in the world, whatever language you use, your spoken language, your number language is always the same. We have a universal language across the world, across cultures, of numbers. So to recap, decimal, base 10, we count in tens; hexadecimal, base 16, we count in 16s; binary, base 2, we count in 2s. And we see a number 123 in the decimal system is equal to 7b in the hexadecimal, is equal to 11111011 in the binary system. In the binary system, leading zeros can be left off. They are assumed to always be there. Very important, as we said, we count from 0. While we're in the number system, let's have a look at a couple of logic operators which we will need to know about when we get to the networking module. In networking, a lot of us will put in a subnet mask 255.255.255.0 and wouldn't really know what we've just put in, but it works. We've always done it. When we get to the networking module, that will be demystified. We'll know exactly what it is. But for the moment, we're just going to learn the logic operators that we need to know for that network module. There are 3, of which 2 are important: the and the or. So when we have something like and, what we're saying is we have a left-hand side and a right-hand side of the and to make the statement true, the left-hand side and the right-hand side have to be true. So we say the sun rose in the morning. Yes, that's true. The sun set in the evening. Yes, that's true. Therefore, both sides are true. This statement is true. We say the horse galloped away, or maybe it did not. So either it galloped away or it didn't. One side of that is going to be true. And for the or, we need only one side to be true for the statement to be true. So it either galloped away or it didn't. That makes a true statement. The third one, which we don't really use that much, but we will go across it, is XOR, which is exclusive OR. So with AND, we have the logic conjugation, which we use, and it looks like an A without the middle bit in it. I also point out that it looks like the tip of an arrow pointing upwards. We'll find out why I've said that in a minute. In software and other places where we use it, we can use it as the AND symbol. So we have a statement here. It's A and B. So if A is true and B is true, the whole statement is going to be true. If either side is false, the statement is false. So let's have a look. So here we have a value for n. N has a value of 3. So here's the and sign. On the left-hand side, it says 3 is less than 4. And 3 is greater than 2. Well, yes, the side is true. It's less than 4. This side is true, it's greater than 3, therefore the statement is true. You say, where on earth am I ever going to use that? I just want to do comms. Well, as we mentioned, it goes in the networking module. And so let's have a quick, brief look at it. So what we have is a decimal number 192. Oh, that looks familiar, you say to me. Yes, that's familiar. That's a Class C number that you'll get used to. And the 255 looks very familiar because you've always put that in as the subnet mask. So here we put them in their binary form. And we have our AND. So we're going to AND these two together and get an answer. So this one is false and that one is true. Therefore, the answer is false. It's false, it's true, therefore it's false. Both of these have to be true to make this true. We find further along here on the left-hand side, it's true, therefore it's true. And the same with the final one. When we convert this binary back to decimal, we see it says 192. Now, how did we know what it would be? Well, AND is like an arrow pointing upwards, which means if you're going to take something and AND it with these numbers like 255, you will always have the top number drop through. So this points to this being the answer. Now, remember the arrow because that will help us in the next one. So we've got OR. How do we know it's OR? It looks like the hull of a boat. Boats have oars. You need 2 of them. That's so. For me, that's how I remember it. So what we have here is that side A or side B has to be true for the statement to be true. If A is false and B is false, the whole statement's false. But if A is true and B is true, then the statement is true. So let's have a look here. N is not 3, so it's any number other than 3. Is N greater than or equal to 4? That's false. That's true because N is not 3. N is any number but 3, so N could be 9. That's greater than or equal to 4. Or N is equal to 3. Yes, true as well, because N is not equal to 3. So that side is a false side, that side is a true side, therefore it works out as true. So we go back to looking at the network side of it. We have a class B168 over 255. Remember the arrow here is pointing downwards. So I think you might immediately say, without working this out, that the answer is going to be the bottom one, 255, but let's work it out. 0 or 1, so it's false or true, is true, and we follow it through and we find that they're all true, which gives us a decimal value of 255. So we know if it's OR, it's going to be the bottom one. If it was AND, it would be the top one. So we look at the exclusive OR. We don't really use this a lot. Sometimes you may use it, but not a lot. So for this one, if either but not both are true, then the statement is true. So if A is true and B is true, this is a false statement. If A is true and B is false, it's a true statement. And if B is true and A is false, it's a true statement. And as I say, here we are with the same worked out as before, but we'll just show it to you because we don't really use it. So to recap, we count using the Arabic numbering system. We start counting from 0. We count right to left. Arabic numbering system or the decimal system counts in tens, hexadecimal counts in 16s, binary counts in 2s. So in the decimal system, the number of 16 is equal to 10 in the hexadecimal system is equal to 10000 in the binary system. We have the AND statement, where both sides have to be true for the statement to be true. We have the OR statement, where only one side has to be true for it to be true. And we have the XOR, where it's either but not both have to be true. Please test your knowledge in the test. Good luck.